the magnitude of the velocity is the magnitude of the velocity vector. Taking the derivative of x and y, we get the components of the velocity vector, and the magnitude of that is how long it is, which is, using the Pythagorean theorem, square root of the horizontal component squared plus the vertical component squared. So at t is equal to 4, we just do the substitution, and that's the magnitude of the velocity vector. Part B. All right, for the total distance, remember distance is rate times time. And we have rate right here in velocity. And we don't want the positives to cancel out the negatives, so we don't really want velocity, we want speed. And the speed is the magnitude of the velocity vector, which is this right here. So the total distance will be the integral of the speed times time. Speed times time. Throw that into our calculator, and we get about a total distance of 46.06 units. Part C, find the slope dy dx. Well, with these parametric equations, that would be dy dt over dx dt. That's dy dt over dx dt. This simplifies to just t, but remember, the instructions ask for this as a function of x. Well, x was given to us as t squared minus 3. So if you solve t, then you know the slope in terms of x. And when we do that, we get x plus 3 square rooted. So the slope is equal to t, which is equal to the square root of x plus 3. Final answer right there.